Knox Game Design. March 2022. Basic 3D Collision.
Welcome everyone to Knox Game Design for March 2022. So this month I'm going to be talking about basic 3D collision. So this is going to be kind of like a follow-up to last month. I did 2D collision, so this is just going along the same path. This is just going to be simple 3D collision. Just going to be talking about cubes, or what's referred to as rectangular solid. Technically a cube is of equal length, height, and depth. So a rectangular solid is similar, but you can have varying lengths, width, and depth. And also spheres. So we're just going to be talking about rectangular solids colliding with other rectangular solids, and spheres colliding with other spheres. I'm not going to be talking about meshes or cylinders or capsules or anything like that. So I'll probably refer to these as cubes. That's what it's referred to as in Game Maker, a cube and not a rectangular solid, but it's defined by a center point. There's multiple ways you can define these, but the way I know, at least in Unity does it, it's defined by a center point and then a width, and going in the X direction, a height in the Y direction, and depth in the Z direction. So to get the right side of the cube, you just take the center X point, then add half of the width to get the right side. Then you subtract half the width to get the left side. And same for the height and the depth. So if you go back and listen to my talk from last month, when do two rectangles collide? We can find that out by determining when they don't collide. So they don't collide when one is above, below, to the left, or to the right. Now it could be to the left and above, or to the right and above, or right and below. But as long as one of those conditions are met, then you know it doesn't collide. So to find out when they do collide, you just take the knot of that. And talked a little bit about De Morgan's theorem, so you can actually do, instead of knotting each of those, you can do one knot and then do the ors of all those conditions. So yeah, that's we're going to kind of do the same thing. But first I'll say we're assuming these rectangles aren't rotated. We're just talking about rectangles sitting flat on its bottom. They aren't rotated. There's probably I know there's a way to calculate that. I just haven't researched it. I know it does it in game engines by default, colliding two rectangles, but I'm not going to get into that here. So yeah, just flat, non-rotated rectangular solids, cubes. So when does it not collide? When it's either to the right, to the left, above or below, just like a rectangle. But also we're going to add the depth in there. So we'll say if it's behind or in front of, then add those two conditions for when it doesn't collide. And the way I think of it, I mean, you can use like the right hand rule, and you got different coordinate systems to determine whether Z goes into the screen, positive Z goes into the screen, or positive Z comes out of the screen. I'm going to be using positive Z going into the screen. And the way I think of it is like a driving game, Rad Race or Gran Turismo, whatever your favorite driving game is. Then whenever you're going forward into the screen, then you're going in the positive direction. So that's kind of the way that I think of positive Z. So here's all the conditions. So we're going to use a rectangular solid, R1, and another one, R2. They'll have properties X, Y, and Z for the center point. And as I mentioned on the other side, they got a width, height, and a depth. So these are the conditions that determine whether it's to the right, to the left, above, below, in front of, or behind. I'm not going to read all that, but basically you're just checking the top bound and the lower bound of the two rectangular solids, or to the left of one rectangular solid and the right of another one, if it's less than or greater than. So here's a couple of examples that I came up with, and you can see there on the right side, I actually implemented these in Unity and took screenshots. I'm not going to go over the Unity code for that. It's not very interesting, but I'll try to post that code up, or at least the demo as well. But here's one example. We got the first cube, the red cube, is -8, x, 4y, z -1, and it has a width of 7, a height of 5, and a depth of 9. Then you got a second cube, x is -10. And you can actually see the 3D coordinates right here. So the red arrow is x, the green arrow is y, and the blue arrow is z. So that's the coordinate system right there. The second cube has a width of 5, a height of 10, and a depth of 3. So we run all those checks, and we find out that that they're all false. So that means that the cubes do collide. Look at the second example here. We got cube 1, position 5, -2, 1, with a width 7, height 7, and a depth of 4. And then you got a second cube, position -7, 8, 8, and a width of 6, a height of 1, and a depth of 3. And you can see in this case, then it is to the right. The red one is, and you can see that in the picture here. The red cube is to the right of the blue cube. So that's a true. And also, it is below the blue cube. So that's also true. And it's also behind. So that's also true. So since there are trues, that means they don't collide. So just like the 2D rectangle, we're just adding the depth into it as well. So the second thing I'm going to talk about is a sphere. So a sphere can be defined similar to a circle by a center point, x, y, and z. So we're just adding the z, and also a radius of r. So very similar to a circle. And actually in some of these examples, I still use c just because I was used to using c for a circle. I didn't want to change it to an S or anything. So when do spheres collide? Very similar to the circle. It's when the distance between the two center points is less than the sum of the two radius values. So if the radiuses overlap each other, then you know they do collide. And how do you find out the distance between the two center points? Well, this is something I actually learned from doing this presentation, but to find the distance between 2 points in 3D, very similar to the Pythagorean theorem. So in Pythagorean theorem, we had a squared plus b squared equals c squared, which turns out to be the square root of a squared plus b squared, and a and b are basically x of the first circle or point. The difference between the x's and the first point and b is the difference between the y's and the point. So we're just adding the z in there. So you can do the exact same thing. So it's almost like a squared plus b squared plus c squared equals d squared. But they don't call it that. So we're basically just doing the differences between the x values plus, and that should be a superscript 2 that's squared, not times 2. I don't know why it didn't come out. Changed that earlier. It didn't come out this presentation mode. But we're going to take the difference between the x, square that, plus the difference between the y's, square that, difference between the z's, square that, then take the square root of all that. That will give you the distance between the two center points of the two circles. So if that value is less than the sum of the two radius values, then you know they do collide. Otherwise, they don't collide. So here's 2 examples. Also did these in Unity. So you got a sphere, center point 3, 5, -1 with a radius of 2. You got a second sphere, center point 2, 5, 3 with a radius of 3. So you find the distance, which you call d here, the distance value, you plug in the values, subtracting the x values, the y values, and z values, square all those, take square root. You get a distance of 4.12, which is a square root of 17. And actually, I have to the 0.5. So again, if you watched the last presentation, if you don't have a square root function in your game programming language or your game framework or your game API, then you can always use power to the 0.5. That will give you the square root. And I'll go back and also mention, again, like last month, that learning how to do the collisions this way, you can implement this in any language. Now, most of the game engines out there, such as Unity, and Unreal Engine, and Godot Engine, they have built-in as well as Game Maker. They have built-in collision detection functions. Not going to get into that. So we can see in this example, the distance between the two circles is 4.12. So the sum of the two radius values, so we got 2 plus 3 is 5. So since 4.12 is less than 5, that means the spheres do collide. Now we got a second example here where we've got a sphere at position 5, negative 1, 2 with a radius of 2. Second sphere has a position of negative 7, 10, negative 4 with a radius of 7. So we plug in the values. We get 269 square root of 269, which is 16.40. So the sum of the two radius values is 2 plus 7. So since 16.40 is greater than 9, then the spheres don't collide. That's all for the presentation slides, but I was going to show a quick little program that I wrote. Clear this magnifier. So I did this on Ruby just because Ruby's fast and I like Ruby. But if anybody out there wants to like do this example, re-implement this in JavaScript or whatever, be my guest. So this is a little program that I wrote. Ruby collision 3D. So basically right here, here's the usage. So this will determine if two spheres or two rectangular solids or two cubes collide. And just pass in those same values, x, y, z, and radius for a sphere, and x, y, z, width, height, and depth for a rectangle. So I actually got the examples already loaded here. This was like the first one right here. So you can see here, it parses these from the command line with X, Y, Z values, with height and depth. And it will actually show you whether it's to the right, left, above, below, in front of, or behind. If those are all false, then I'll say collision detection yes. So here's the second example. So it reads in the values, then it finds true that it is to the right, and it is below, and it is behind. So then I'll say collision detection no. Here's a sphere example. And by the way, you do have to put it between double quotes. Otherwise, especially if you have spaces in here, I'll see it as different parameters. So it has to be one parameter. So here it reads in your two spheres, x, y, z, and radius values, and it calculates the distance between the two center points of the two spheres, and then the sum of the radius values, and it determines since the distance is greater than sum and radius, then it does not collide. Then here's the other example. So it calculates the distance 4.12, sum of the radius is 5, so it does collide since the distance is less than the sum of the radius value. So here's the code up here. Like I said, it's in Ruby. So basically we have a sphere class, nothing special going on here, x, y, z, and a radius value, and a toString method, QS, so we can print it out. Then a cube class, x, y, z, width, height, and depth, and a toString. Got a sphere collision check, which takes two sphere objects as parameters, so that's where we're calculating the distance right there. Then we calculate the sum of the two radius values. We display the distance and the sum, two radius values. Then it just does that simple check. If d is less than the sum of radius, print yes, it does collide. Otherwise, it doesn't collide. Here's the rectangular solid or cube collision check. Takes two rectangles. So here it's going to go through and like check each right, left, above, below, in front, behind. Then it has this big and. So I didn't do De Morgan's here. So I do if not is right, and not is left, and not is above, and not is below, not is in front, and not behind. Then print yes, it does collide. Otherwise, print no. So I could have did not, then one big paren, is right, or is left, or is above, or. So here we're just parsing the input from the command line, taking out the spaces there, and then doing a regular expression to match if it is two spheres, which it actually uses C just because I wanted to keep it similar to the last program that I wrote. So it takes those two parameters and passes it to parse sphere. That's kind of hard. That's kind of a tongue twister there. So that gets out the parse sphere, gets the X, Y, and Z values out of there. I also added another parameter. Can't find it. Yeah, if it matches C, then if you just put rand in there. So that's one other thing that I did. So you can go here. If you have two circles or two spheres, you can just put rand in there, and then it will randomly generate one of those or both of them. Right there, X. That randomly generates those values, and you see rand right there. Or you can put rand for both of them. That's going to generate two completely random. I think I just did X, Y, and Z from -10 to +10. Like if somebody wanted to, they could go in and add an option to specify the random values, and it generates a random radius from 1 to 10. I didn't want to do 0. That'd just be a point. But yeah, so you can get different values every time, so you can play around with that, generate different examples, and also you can do two rand rectangles. So here's two randomly generated. I should have said rectangular solids. Two rectangular solids, and that'll calculate all those conditions. Here's one that's true, so that means they don't collide. Like if you run this enough, you'll eventually find one where they're all false. They do collide right there. So going back to the code, that's parse sphere. Then parse cube is the same, using a regular expression, reading out those X, Y, Z width, height, and depth values, and also we have the optional rand right there. This is where we're generating the random cube. Otherwise, if it doesn't match a regular expression, then we print syntax error. Then display usage just displays how to use the thing. And yeah, that's where you started up right there. Actually, I had this in here. I need to take this out because I was doing random a different way. I should just have one parse input and get another one. But yeah, that's basically it. So yeah, I was trying to keep this one pretty short. As I mentioned earlier, there is a lot more to 3D collision, such as rotations and other objects. I think like a capsule is basically just two spheres with a cylinder in between. So I didn't get into cylinders. I'd have to research to figure out how to do a cylinder, but it's probably not too difficult. But yeah, that's it. Going to be short and sweet. I will say I won't mess up this time, but let me go back to the Knox game design website. I'm going to mention that we do have Ludum Dare 40 or 50, Ludum Dare 50 coming up. So we've been talking about that. The Knox game design Discord channel. Should bring that up. Mention some of the things that people are working on. Yeah, Knox game design. So Blackjar released his game Caverns of Evil on Discord, so check that out. Links on the Discord channel. Try to post that on the website too. But yeah, a lot of people posting cool stuff on the show off channel, like your Locksmith Army released his Labyrinth game as well on Steam. But we did have some discussion about. So Arctic's been working on animating textures, different textures he's created. But going way back up, we did have a discussion about Ludum Dare 50. You can go to ldjam.com. So yeah, we actually have 9 days. So we're planning on doing a kickoff. Sounds like everybody's okay with getting together at Paranera. We're at again on North Peters Road. It is Ludum 50. That'll be April 1st until April. I guess it's April 3rd for the Compo 48 hour, or Monday, April 4th for the 72-hour jam. I'll probably do the Compo as usual. Theme suggestions are open. I'm not sure if voting is open yet or not. Yeah, and they're still in theme slot around right now. So, if you're interested in doing Ludum Dare, just post in the Discord channel or come out and meet with us. Plan on getting together probably 7 p.m. and theme announcement is 9 p.m. Eastern Time. So next month I anticipate just doing a game show-off type deal for Ludum Dare 50. So anyway, that's going to wrap it up for March 2022. Appreciate everyone out there listening and watching.